So good morning students, welcome back. Today in this chapter EMI, electromagnetic induction, we are going to discuss some basic question, reasoning question. So let's start. That question once came in board examination. So let's start the numerical. I'm going to read the language of this question. Predict the direction of induced current in metal ring marked as 1 and 2 placed in the same plane where current I is increasing. Look at students, we are given a wire. In that wire, current is flowing from A to B, that is increasing current, okay? And we are given two metal ring marked as 1 and 2. So we have to find the direction of induced current in ring 1 and 2. Actually, two factors are responsible. First, Lenz law, and second, induction will take place. So due to increasing current, whenever we change the amount of current, it induces flux and EMF. Okay. So current will induce in ring 1 and ring 2 as by induction. And as per Lenz law, the direction of induced current will be opposite for this factor. It means this is increasing current. So that current will try to decrease this current. That's why the current in ring first will be in clockwise direction. This current will oppose, the induced current will oppose the current of wire as per Lenz law, because Lenz law states that induced current and direction of induced current and EMF are in such a way in circuit that it always opposes the factor which are responsible for its production. So induced current produced in ring due to increase of this current. So that current will oppose of its increment. So opposite to this arrow will be that. It means direction of induced current in ring will be what? Clockwise direction. And about this, okay, it also opposes of that current. So opposite of this arrow, like this. So this will be what? Anti-clockwise. Two factors are responsible. Obvious, induction will take place because this is increasing current. There will be change in current, and whenever there is change in current, it produces induction, self-induction. So induction take place, and as per Lenz law, the direction of induced current in both the ring will be opposite of direction of current in this wire. So opposite of this in this direction, so this will be clockwise, and opposite of this that. So that will be what? Anti-clockwise. So direction of induced current in clockwise in first ring, and direction of induced current anti-clockwise in second ring, as per Lenz law and induction. This question once came in board examination, and such types of question generally comes in examination. That is a reasoning question. Understood, students? Now students, question second and third. This we are given a metallic ring, that is coil, and that is a bar magnet. What happened on bringing north pole of a bar magnet towards the coil? So we have to find direction of induced current in ring, this metallic ring. So when we bring bar magnet close to the coil, passing flux through the coil will change. Okay, and this is said to be electromagnetic induction because current, okay, and EMF will generate in this due to change in magnetic flux. So what is the direction of that current? Actually, on bringing north pole, here's the again Lenz law is applicable. Lenz law always opposes the factor which are responsible for its production. Current and EMF will induce in this coil due to, okay, to take north pole towards the coil. This side start behaving like a north pole. So it will oppose the factor, okay, which are responsible for the production of current and EMF. Which factor is responsible? We are taking bar magnet close to coil. And how it can oppose of that bar magnet? Start behaving like north pole, and north will repel, so it will oppose a factor. Okay, actually current and EMF generating this coil due to closeness, okay, of bar magnet, and this coil start behaving like a north pole and opposing that factor. That's why in north pole, okay, direction of current will be anti-clockwise. So what will be direction of induced current in this coil? Anti-clockwise, because we are taking north pole towards the coil and it will oppose of that factor, so it also behave like a north pole, and north will repel. So it is opposing the factor of north pole, okay, because north pole is responsible, closeness of north pole is responsible for the production of current and EMF, because when you bring north pole, passing flux through the coil will change and that produce current and EMF. So to oppose this north pole, it also behave like a north pole, okay, and in north pole we know the direction of current will be what? Anti-clockwise. What about this? In this we are bringing north pole away from the coil, so it again opposing of that factor. We are taking north pole away, passing flux will decrease, okay, it produce current and EMF, but this coil, as per Lenz law, this coil will also oppose of that north pole, like start behaving like a south pole. In this time we are taking north pole away, and this coil will prevent of that to moving away of that coil, bar magnet. We are taking bar magnet away, but it will attract the bar magnet. How? It start behaving like a south pole, okay, and we know in south pole direction of current will be what? Clockwise direction. So main induction is taking place, as well as the most important Lenz law is applicable. Lenz law is always oppose factor which are responsible for its production. Okay, students.